Good day, everybody. And once again, your favorite uncle is back. And I hope for those of you that were writing or are writing, that your exams are going well. All right, so today we are going to cover the grade 12 paper 2 on mathematics. So if you haven't subscribed, please just make sure that you're part of the family. All right, and let's get right into the business of the day. Right, so we begin with question 1. They say to us we've got truck drivers that travel a certain distance and have a rest before traveling further. The driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is kept in the table below. Now, ladies and gents, we know question 1 has to do with stats, and stats has to do with a lot of calculator work, right? So they've given us the distance traveled in kilometers as our x variable, and they've given us the amount of rest time in minutes as our y variable, right? So let's whip out our calculator. Of course, mine looks a little bit different, but if you've got a Casio calculator, you're going to go into mode and you're going to press option 2 for stat, okay? The first question they wanted us to determine the equation of the least square regression line. And you'll see that after you've pressed mode and you press stat, option 2 has got that a plus bx. So you're going to press option 2 again. So on my calculator, it almost looks similar, right? I'm going to press stat, okay? And I am on my one, it's option 4, that a plus bx. Okay, so now let's insert the data. So this is going to be 180. Okay, that's 200. The next one, that's 400. Please, every time that you insert the data, you press equal to, right? To insert the next one. So that's 600. That's 170. Right, we shouldn't waste a lot of time here, ladies and gents. Let's do the best that we can. We've got 350, and the next one is 270. The next one is 300. Okay, that's the last one. All right, so now for my y variables, so I've got 20, the first one. Okay, let's just make sure that's correct. So that's 20, that's 25, that's 55. That's 120, that's 15, that's 50, and we've got 40 as well as 45. All right, so there's our data. So what we're going to do, I'm going to say shift, and I'm going to press option 1, that's stat, okay? Remember, what am I looking for the regression calculation, right? So you're going to do exactly the same on your one as well. In my one, it gives me the A, the B, as well as the R value, right? But in your one, you are going to actually choose the value for A. You'll see them in your calculator, right? So let me write them down, okay? Let me just remove this. Okay, right. Let's write that down. So we know that for 1.1, okay, we said our A value, okay, let me write down the A value, that's negative 23.85, okay, and my B value is 0.227. Okay, let's just say 0.23, right? Okay, so what is my least square regression line? Okay, that's going to be y. Remember, you write it as y is equals to a plus bx. Okay, remember, we don't write it as the normal straight line equation, right? So that's negative 23.85 plus 0.23x. Okay, so that is our least square regression line. Okay, so 1.2, they say if a truck driver travels 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. Right, so in this case, what that simply means is that we're going to use our least square regression equation right, to predict. This is called interpolation, that is within the line, right? So that's minus 23.85 plus 0.23 into 550. So we're going to use 550 as our x value. All right, so let's calculate that quickly. Okay, and I'm going to come back to my r value. In fact, I might as well just write it down. So my r value is 0.98. Okay, right, so now in this case I've got my calculation there. That's negative 23.85 plus 0.23 times 550. And we get 102.65. So I get 102.65. So that means that the amount of rest time, okay, so the amount of rest will be equal to 102.65 minutes. All right, so those are the amount of minutes in which our driver is going to rest. Okay, right, so let's go to the next question. So 1.3 says write down the correlation coefficient of the data. So you are going to go back to your calculator to find that correlation coefficient. I think it's option 3 for you, right? So I already wrote it there. My correlation coefficient is 0.98. And what does that value tell us? That, well, that's a very strong correlation, right? A positive strong correlation. And finally, they say to us, interpret your answer to question 1.3, right? Okay, so we are going to tell them that this is a very strong positive correlation. Okay, so it is a very strong positive correlation. Okay, so please, if you don't understand what all of this means, it means that you have not watched my video on statistics, and it would do you a world of good for you to go and watch that. All right, awesome. Right, as we move on to the next part. Now the next portion says, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. Now, this is single variable data, right? So in this case, we're going to go back to our calculator. And what we are going to do, again, we're still in stat mode, right? But this time around, we are going to go to one variable, right? So I've got 100. Let's insert our data. We've got 150. We've got 130. We've got 200. We've got 50, and we've got 180, right? Our data still continues. We've got 200 again, and that's 200, as well as 190, right? So that's the last one. They say to us, calculate the mean amount of money he spent at each shop. So to get the mean amount of money, again, we're going to say shift. I'm going to go to my stat mode, right? So what am I looking for now, right? One variable calculation. So my calculator gives all my data as just all of them at once. So my mean in this case is 150. Okay, and the second question says, calculate the standard deviation of the data. So my standard deviation, right, of course, in your calculator again, you're going to go to the stat mode and look at the standard deviation, the single variable data there, right? and that means that my standard deviation, right, if I go back there, can you see my standard deviation is 5 root of 102. Okay, we can express that as a decimal, 5 the square root of 102, right? And this time around, for 1.3, in fact, let's try and calculate that. What's 5 root of 102? That's about 50.5, shall we say? Right, so that's 50.5. So the final question, they say to us at how many stops did the driver spend an amount of money that was less than 1 standard deviation below the mean. Now remember, 1 standard deviation below the mean simply says I'm going to take x minus the standard deviation. So if we say our mean was 150 and our standard deviation is 50.5, right? So what does that give us? So that's 150 minus 50.5. That would give us 99.5. So 1 standard deviation below the mean is 99.5. Now, they said at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? So what is less than 99.5? Right, I think there's only one variable or one value there, and that is 50, right? So clearly the driver only did that at 1 stop. Okay. Right. And ladies and gents, that is your stats section. Really, I expect you guys to get full marks on this section, right? But without any further ado, let's go to the next question. All right, and so we hop on to question 2. Right, so they give us there, at a certain school, the staff committee wanted to determine how many glasses of water the staff members drink during a school day. All teachers present on a specific day were interviewed, and the information is shown in the table below. Right, so they've given us that table. X represents the number of glasses, and we've got the number of staff members in each class, right? So they say to us, complete the cumulative frequency column provided in the table in the answer book. So what I did, I took the liberty to copy the one from the answer book so that we can try and complete it. So remember, how does cumulative frequency work? Right, so I'm going to just take that color there. So between 0 to 2, so we've got 5. Okay, so it's that answer there. Right, now to get the next answer, it's going to be 5 plus 15. I get 20. Right, 20 plus 13 gives me 33. Right, 33 plus 5 gives me 38, and 38 plus 2 gives us 40. So it's a total of 40 people that were interviewed. So the cumulative frequency, is drawn in that manner. Right, and please remember, guys, they could have easily asked us to draw an ogive of this. Okay, and I just want to show you just a simple illustration of what that ogive looks like. I don't know how you want to call it. It's an ogive. Right, remember that you take your upper boundary values, right? So which means for x, I'm going to take 2, 4, 6, 8, and 10. So these are my x values, right? Of course, that represents the number of classes. And for y, that would be my cumulative frequency values. Now remember, the highest value is 40, okay, and the lowest is 5. So I'm going to just take that in 5. So that's 5, 10, 15, 20, 25, 30, 35, and 40. Okay, I'm just going to extend it a little bit. Okay, so remember, so what I do is my first value 2, 4, 6, 8, and 10. So at 2, remember that my value, the associated cumulative frequency value is 5, right? And at 4, right, my cumulative frequency value is 20. Okay, so that's 5, 10, 15, 20, 25, 30, 35, 40. I'm just showing you this because I want you guys to know how to draw that ogive, right? In case you didn't know, right? So number 4, the second one, so I'll take 4 there. The associated cumulative frequency is 20. So this is the number. And at 6, I've got 33. 6 and 33. So around there. Okay, and at 8, I've got 38. Okay, so I've got 38. Let's put it there. And at 10, I've got 40. Okay, there's my 40 there. And what you would do is just show your ogive there. Okay, like that. Okay, so that's how you draw your ogive. But of course, this is not what we were asked. This is me paparing. Okay. All right, so let's go on to the questions that we actually have been asked. Right, so they said to us, how many staff members were interviewed? And we know that very well from our cumulative frequency. We found out that it is 40. How you can always get that as well is that you just take the sum of all of that. That should give you the number of staff members. Right, so the next one, they say, how many staff members drank fewer than 6 glasses of water during a school day? Right, now I want you to note, in this case we had, all right, so let's go to our table. It's much easier to look at it from there. Right, now remember, in this case, as I just removed those values. So that was 5, and we said that was 20, and this is 33. Right, so remember that from here going up, all of these, right, drank fewer than, the fewer than 6. So the actual number is 33 people, or you can just simply sum all of these up. Okay, so all of those drank less than 6. So that means that in total, that would be 33 staff members, right? And then finally, they say to us, the staff committee observed that K teachers were absent on the day of the interview. It was found that half of these K teachers drank from 0 to fewer than 2. Okay, so which means, so half of these, so that's going to be half K there, right? And then the other ones, they say, they drank fewer than 2, and then glasses of water per day, while the remainder of them, from 4 to fewer than 6. So the other ones were actually between here. So remember the remainder would be half of K as well, right? And then they say when these K teachers are included in the data, the estimated mean, right, is 4 glasses of water per staff member per day. How many teachers were absent? Right, now, ladies and gents, remember, so what you do when you calculate the mean here, so what we do is to get the mean value, right? Let me just remove all of these. Okay, so to get my mean for the cumulative frequency, right, I will always say x bar, the mean. Now remember, what I simply do is I am going to take the midpoint of my values there. Okay, so let me just use a different color. Right, so I'm going to use my midpoint of this value here. So what would be the midpoint? The midpoint here is 1. The midpoint there is 3. Midpoint is 5. The midpoint is 6. The midpoint would be 7. The midpoint here would be 9, right? So my midpoint values, okay, and I'm going to multiply by the number that is here. So in this case, this is going to be 5 plus half k. You remember that, right? And the other ones were here, half k as well. All right, so that's half of k. That was between 4 and 6. So I'm going to take all of those numbers, right, my midpoints multiplied by that, and I'm going to divide by the total number. Now remember that the total number will no longer be 40, but it will be 40 plus the k that were absent, right? So let's do that quickly. So this is going to be, it's going to be my midpoint. Okay, I just want to go back to the white. So it's going to be my midpoint. So that's 1 multiplied by 5 plus half k plus 3 times 15 plus we've got 5 times 13 plus a half k again, and we've got plus. Okay, you know what, I have to try and fit all of these values into one line, so allow me to just make a little bit of space here. So let's do it quickly. So 1 times 5 plus 1 over 2k, and we've got plus, we've got 3 times 15. So that's 3 times 15 plus we've got 5 times 13 plus 1 over 2k. We've got plus there, another 7, so we've got 7 times 5, and we've got plus, in this case we've got 9 times 2, and in this case divided by, remember this is divided by 40 plus k, which is the total number that we had, and remember this is equal to, remember they said to us the mean, the estimated mean is 4. That's 4 classes, right, per staff member. So all that we need to do is to try and solve this as much as we possibly can. So I'm going to say 4 over 1. So if we cross multiply, right, let's start dealing with what's at the top there. So I've got 5 plus half of k. Right, we're going to deal with everything that has k in it. 3 times 15, that's 45, plus, in this case, I've got 5 times 13, okay, 5 times 13, that gives me 65, plus 5 over 2k, right, and then plus 7 times 5 is 35, plus 18, right, and all of this will be equal to 4 times 40k, 40 plus k rather, that's 160 plus 4k. Right, now let's try and work out what, we've got only 2 terms for k here. It's half k plus 5 over 2k, which will give me 3k, and let's take everything else. So that's 5 plus 45. Okay, let's do that quickly. So this is 5 plus 45. plus 65 plus 35 plus 18. Okay, so we added all of that up and that gives us 168, right? So I'm going to take that value, okay, this is equal to 160 plus 4k, right, minus 168. So the 168, I just took the sum of those values, took it to the other side. Okay, right, so if I take this would be 3k minus k, which will give me minus k. Okay, minus 4k. So 3k minus 4k gives us negative k. 160 minus 168 would give us negative 8. So which means that the number of staff members that were absent would be 8 members. All right. And there we go, ladies and gents. So for you to keep in mind, right, every time that we want to calculate the estimated mean, right, remember that we are going to always take the, we always take, in this case, you'll always take, right, the midpoint between your class values, right, and then you multiply it, so the midpoint multiplied by your data, right, whatever data that you've got there, right, and you take the sum of that and you divide it by the total number. In this case, that's how you get your estimated mean. And ladies and gents, that is how the cookie crumbles. We will go on to question 3. All right, ladies and gentlemen, let's start with question 3, right? So we've got there in the figure, which is L, which is negative 4 and 1, S 4 and 5, and N, which is negative 2 and negative 3, are vertices of a triangle having SLN equal to 90 degrees. Now they say LN intersects the x-axis at K. Right, so let's go into this question. Right, so they say to us, we need to calculate the length of SL. Now I want you to note in this case for SL, right, first of all, let me just write down the coordinates. So the coordinates of S, you remember that they were given there, 4 and 5. Okay, so we've got 4, 5 there. And the coordinates of L, okay, I think they were negative 2 and negative, oh no, actually negative 4 and 1, right? So that's negative 4 and 1, that's in the second quadrant. So the distance SL, that would be the square root of, right, so you remember we use x2 minus x1 squared plus y2 minus y1 all squared, right? So if we substitute our values, there we've got our x2 value. Okay, so we've got 4 minus a negative 4. So this becomes 4 plus 4 squared plus. What about our y values? So that's going to be 5 minus 1, right? So that's 5 minus 1 all squared. Okay, and this gives us 8 squared, which is 64. Right, so the square root of 64 plus 5 minus 1 all squared, that's 4 squared, which gives us 16. And this will give us the square root of 80. All right, so this would be square root 80. Right, now if you think about 80, that's 16 times 5, right? And in this case, I can actually write it in a much easier way as 4 root 5. Okay, right, so let's go to the next question. So 3.2, they want us to calculate the gradient of Sn. Right, now n is negative 2 and negative 3. So let's keep that in mind. So that's minus 2 minus 3. Okay, but we remember that S is 4 and 5, right? we were given that there. All right, so the gradient of Sn, that's y2 minus y1 divided by x2 minus x1. So let's substitute there. So I'm going to take that as my y2. So that's 5 minus a negative 3, okay, divided by 4 minus a negative 2, right? So if I take 5 minus a negative 3, that gives me 8. Okay, so 5 plus 2, 4 plus 2 rather, gives me 6. And so if I make that easier, that becomes simply 4 over 3. All right, so that's my gradient for Sn there. Okay, so 3.3, they want us to calculate the size of angle theta, right? The angle of inclination. Now, keep that in mind, ladies and gents. Now that we know the gradient of Sn, we can use the tangent, right, being equal to the gradient. So we know that the gradient is 4 over 3, right? So I'm going to say the tan of theta is equal to the gradient of Sn, right? So in this case, that means this is 4 over 3. So to get theta, we say the arctan of 4 over 3. Right, so let's calculate that quickly. That's 4 over, the arctan rather, of 4 over 3. Okay, so I get 53.13. Okay, so that is our value there for the angle theta. All right, now let's go to the next question, 3.4. So for 3.4, they want us to calculate the size of L and S. So if we go to our diagram there, L and S is actually this angle over here, right? Now, well, we can do it this way, ladies and gents. So if you think about it, if we look into this triangle over here, right? So L and S, right, is this angle over here. So we can find the angle of inclination of the line LN, right? And now, please, I want you to note, this angle over here is equal to that angle, right? They are vertically opposite. And in this case, this angle over here would be equal to that, okay? So that simply means that to get the angle, to get that angle, we'll simply say 180, right? Sum of angles on a triangle, 180 minus this angle minus that angle over there, right? So remember, so we're gonna get, we already know the angle theta, right? So we already know that this is 53.13. All we need to get is that angle there, right? So let's do that first. So let's say the gradient of Ln, okay? So the gradient of Ln, all right, so y2 minus y1. So remember the coordinates of L, we had them then negative 4 and 1. Okay, L was negative 4 and 1. And we said that N is negative 2 and negative 3. Okay, right, so that gradient would be equal to y2, that's 1, minus a minus 3, so that gives us 1 plus 4, divided by, right, so we said negative 4 plus 2. And so that gradient, we get that to be, that's 5 over negative 2. Okay, So please keep that in mind. So actually, I'm incorrect. I was already thinking of the answer here. So this is 1 plus 3, right? And this is negative 4 plus 2. Yes, I am correct there. So this gives us 4 divided by negative 2. So that gradient is actually equal to negative 2. So I'm going to say, well, the tan, okay, of alpha, okay, is equal to negative 2. And so alpha would be equal to the arctan of negative 2. Right, and if I get that, shift a tangent of negative 2. All right, I get negative 63.43, right? But remember, in this case, I'm getting the negative, and I'm going to show you just now. Okay, right, that has a negative gradient over there. So in fact, what it gives me is this angle here. And remember that we take the angle of inclination from the right hand side. So usually we are getting this angle over here, but in that case we got this guy to be 63.43. So that means this angle over here is 63.43. They are vertically opposite, right? So let's find L and S, right? So angle L and S, so therefore angle L and S would be equal to, right, so that would be 180 minus 180 minus, okay, the two angles there, that's 63.43, right? Let's say plus the other one was 53.13. Okay, so let's get that angle there. So that's 180 minus, that's 63.43 plus 53.13. Right, and I get that to be equal to 63.44. And that's our angle L and S, right? So that's the size of L and S. Now, guys, of course, there could have been another way that you can calculate that angle. Because that's a 90-degree triangle. Now, please, I want you to note there, right? What I could have done is I already know the length of SN. I know the side here, SN, right? So I could have found either the length of LN and use the sine of angle theta. The sine of angle LNS, right? So the sine of this angle, that's opposite over the hypotenuse, right? So in that case, what would that give me? It would give me the size of that angle there. Right, and that's how the cookie crumbles. Let's go on to the next one. They say that they determine the equation of the line which passes through L and is parallel to SN. Right, remember we found the gradient of SN, right? The gradient of SN, if you remember, that was 4 over 3. But they said this line passes through L, right? The coordinates of L are negative 4 and 1. Right. So we know that that line, so for 3.5, would be y is equal to, right? So the gradient of that line would be equal to the gradient of, we said the gradient of Sn. Yeah. So this would be y is equals to 4 over 3x. Why? Because they are parallel, right? Plus c. But how do I find the c value? So now they said it passes through L. And we know that L, the coordinates of L, I just want to make sure that I am absolutely correct. I think they are negative 4 and 1. We can go back there just to verify. Yes, they are. So that's negative 4 and 1. So I'm going to substitute this point here, right? When y is 1, x is -4, right, plus c. Okay, so let's find the c value. So we've got 4/3 times a -4, which should give me -16/3, right, plus c. Okay, if I take that to the other side, our c value would be equal to, so that's 1 plus 16/3. Okay, so that gives us 19/3 if I'm not incorrect there. Okay, we can verify it. So 1 plus 16/3, that definitely is 19/3. So the equation of that line would be y is equal to 4/3x plus 16/3. Right, and that's how we get to that line there. Right, and then they say we must find, we have to find the area of triangle LSN. Right, so the area of that entire triangle, right? So in this case, this is a 90-degree triangle, right? What we can do is that we already have the length of, let's see. Okay, we know this angle over here, all right? And we know the length of SN, right? You remember we found it. We can find the length of LN, right? So the length of LN, yeah, we found SN to be 4√5. Okay, so firstly, let's say for our 3.6, so I'm going to find the length LN. Okay, that's going to be, right, so remember that's x2. So remember our coordinates for L, that's 4, -4 and 1, right? I want to be to make sure that I'm absolutely spot on. And n is -2 and -3, right? That's what we said. Yep. Okay, so that's -2 and -3. Right, so I'm going to find the distance Ln. So this would be -4 x2 minus x1. So this is -4 plus 2 all squared plus y2, that's 1 plus 3 all squared. All right, so what do we get there? We've got -4 plus 2 gives us -2 squared. That gives us 4. So we've got 4 plus 4 squared again. That gives us 16. So that gives us the square root of 20, right? 20 is 4 times 5. So we can write this as 2 root of 5 units, right? Okay, so then we also know the angle LNS. So to get the area of any triangle, remember, you must take two sides and an included angle, right? So two sides and included angle. So what would that give us? That would give us the area of LNS, okay, of triangle LNS would be half. So what are my two sides? It's going to be Ln multiplied by Sn, right? The sine of the angle in between them, that is triangle angle LNS. Okay, I know that angle there. So this would be a half of 4√5. Okay, so that would be 4√5 multiplied by 2√5, and this would be the sine. I think we got 63.44, right? Okay, so anytime that you've got, you could have also found the length of SL, right? And in that case, in fact, we already had, let me just make sure that I am correct there. No. Actually, we've got SL, which was 4 root 5, right? And we just found LN, which was 2 root 5. Yeah, almost made the error there. Right, remember the angle in between them is the 90 degrees, right? Okay. And we know that the sine of 90 is 1. So we could have just used sine of 90 there. Okay. Yeah, sorry about that. So this is sine of 90. Or it was just half base times height. So in that case, what will we get? So we're going to have 4 times 2, which is 8 times 5, right? Okay, so if we look at this, that would be 4 times 5. So this would give us 20. Okay, so that's 20 square units. All right, so that is the area of triangle. So this would be the sine of. So the angle there would be NLS. NLS. Okay, right. So apologies about that. So if you wanted to use that that angle there, so that means that we would have to get the length of SN, right? So I just realized that we actually had the length of SL, right, as well as the length of LN. So the included angle in between those is angle L. All right. Okay, finally, not finally, almost done. They say calculate the coordinates of P, which is equidistant from L, S, and N. Right, so now I want you to note, we're looking for P, right? And they say it is equidistant from L, S, and N. Okay, equidistant from L, from S, and N. So ladies and gents, I want you to consider, so for this to be equidistant to S and N, right, it would mean that it would be sitting somewhere over there, just thinking about it, right? So it should be the same distance from S to N, right? So S to N. So the only way, thinking about just those 2 points, the only way is if it would be the midpoint of Sn, right? And remember, it should also be an equal distance again to L as well, right? So think about that even as a circle, right? So it would mean that, that's the center of a circle, right? Yeah, I'm sure you're familiar with what I'm saying. So in this case, if you were to draw that circle there, so it would mean that L, S, or rather whatever the circle center is, let's call it M, right? So it would mean ML is equal to MN, or actually they call that point P, right? So PN would be equal to PS would be equal to PL, right? So in that case, if it was a circle, it would make that point the center of the circle, right? And you can see that therefore or rather SN would be the diameter of that circle, right? So let's just find the midpoint of SN, right? Okay, let's do that. So the midpoint, so we're going to find, so P would have the coordinates. Now, I almost want to always check my points. So we said coordinates of S, that 4 and 5. Right, the last thing I want to do, and we said this is N, right? And the coordinates of N, okay, let me go back there. That's -2 and -3. Okay. Right, so the coordinates, so in this case, the midpoint, remember our midpoint formula, that's y2 plus y1 over 2. Okay. Right, I started with the 1 here, so let's just for consistency. Right, so the point P in this case would be, so that's 4 minus 2 divided by 2. Okay, so that's 4 and minus 2 divided by 2. And for y values, so that would be 5 minus 3 divided by 2. And so the coordinates of P, 4 minus 2 will give us 2. 2 divided by 2 gives us 1. And 5 minus 3 gives us 2 again. 2 divided by 2 gives us 1. So the coordinates of P will actually be 1 and 1. All right. So that is, okay, so that was 3.7. As we move right along to 3.8. So they said calculate the size of angle LPS. Okay, let's look at that. LPS. Okay, so we are looking for the size of angle LPS. All right, so there it is there. Now, if you think about it, if we looked at it as a circle, oh, okay, actually, quite interesting. If we looked at it as a circle, ladies and gents, I'm sure you can see what happens, right? So that would mean, think about it, we can apply angle at center because both of them are actually subtended by the chord LS, right? So I'm going to use angle at center must be twice angle at circumference. The angle at circumference in this case would be angle LNS, right? So simply that angle LPS would be twice LNS. I'm sure that you can see it, ladies and gents. I think it really helped for us to have it. Okay, so we're going to say that angle LPS is equal to 2 times angle LNS. We are using angle at center equal to 2 times angle at circumference. Okay. Right, so that's going to simply be 2 times, I think it was 63.44 if I remember correctly. So we're going to say this is 2 times 63.44, and that gives us 126.88. And that's how we'll get that angle, ladies and gents. I'm sure there's a myriad of other ways that you could have used, but I will keep it there for now. This question has been long enough. Okay, so that is really how the cookie crumbles for this question. Let's hop on to the next question, please. They say to us in the diagram, with circle with center O has an equation x squared plus y squared, which is equal to 20. G, which is t and 0, is the center of the larger circle. A common tangent touches the circles at D and F respectively, such that D is P and -2. So what I'm going to do, ladies and gents, is I'm just going to highlight that point there so that it just becomes easier for us. They said that point there is P and -2, right? and they say this point lies in the fourth quadrant. Okay, so let's quickly have a look at the first one. They say given that D is P and negative 2 on the smaller circle, show that P is equal to 4. Now all we do is we're going to substitute that point into the equation of the circle, right? So we remember that the equation of our circle is x squared plus y squared, which is equal to 20. So what I'm going to do is where x is P, so I'm going to substitute, so that would be P squared plus our y squared is negative 2 squared, and this is equal to 20. Right, so what does this give me? So P squared is equal to, now 2 squared is 4. If I take it to the other side, it's 20 minus 4, which is equal to 16. So P squared is equal to 16. So we can say P is equal to plus minus 4. And so keep in mind that we are looking at the fourth quadrant. So we are only going to consider the positive value. So we found out that P is actually equal to 4. All right. Now, I hope that is good, ladies and gents. Right, let's go to the next part of this question. They say E, which is 6 and 2. So we need to go and put that there. Okay, so they told us that this point is 6 and 2. Right, so if we read that, they say, is the midpoint of DF, determine the coordinates of F. All right, so now they said it's the midpoint of DF. Now remember, from our midpoint formula, right, it means that the x values at E will be equal to the x value at D plus x value at F divided by 2. Right, so that means we know the x value at E, this is equal to 6, and x value at D, this is 4, plus the x value at F, this is what we are looking for, and this is divided by 2. Now if we cross multiply, that's 2 multiplied by 6, which is 12, minus 4, that gives us 8. So the x value at F is equal to 8. So I'm just going to put that value there. So the x value at F is 8. And then we'll do the same in finding the y values, right? Please, if you don't mind, I'm just going to remove this. Okay, so for the y value, it's always easier for me to work on this diagram. So for the y value, rather, we're going to say the y value at F, again, exactly the same thing. That's y value at D plus the y value at F divided by 2. Y value at E, rather, sorry. Y value at E was 2. So this is 2 is equal to, the y value at D is negative 2 plus yf divided by 2. And if we take that, so that's 2 times 2, which is 4. Okay, and we've got plus another 2, so which means the y value at F is equal to 6. So that means that the point F has got the coordinates 8 and 6. All right, so that is how we are going to get that value. Right, so the next question says that we need to determine the equation of the common tangent df in the form y is equal to mx plus c. All right, so let's do that quickly. So we're looking for the common tangent df. Now, if you don't mind, I'm just going to answer this question. Now, firstly, let's find out the gradient of the line df. So the gradient of df, that's y2 minus y1 over x2 minus x1. Now, please, I want you to note, ladies and gents, that I am going to take the point at F and the point at D, right? Okay, so if we take those 2 points, right, my y2, that is 6, minus y1, which is -2. So that's minus a -2 divided by x2, that's 8, minus 4. And what do I get for that gradient? That's going to be 6 minus a -2, that's 8, divided by 8 minus 4, which is 4. So that's 8 divided by 4, so that gradient would be equal to 2. Right, but we're not done. We're looking for an equation. So in this case, I'm going to substitute the point E to get the C value. So this is y is equals to 2x plus C. So I know when y is 2, okay, x is 6 plus C. And so that's 2 times 6, which is going to be 12. Right, if I take this to the other side, it becomes -10. So C is -10. So we can write that equation in the form y is equal to 2x minus 10. All right, ladies and gents, I hope that makes sense. Apologies that I work on this diagram, but it's always much easier to work on the diagram so that we don't keep toggling up and down, right? Okay, so let's go to the next part of the question. So they say show that calculate the values of t, show all working, right? So now we are looking for the coordinates of t. Now what you need to appreciate, ladies and gents, is that if I look at the line FG, that is the radius to the big circle. But what happens between a radius and a tangent, right? So in this case, they would be perpendicular to each other at the point of tangency, right? So which means that the line DF is actually perpendicular to the line FG, okay? So now I can say, well, the gradient of DF multiplied by the gradient of FG, this should be equal to -1, right? Now, please remember to state the reason for that. Why are they equal to -1? This is going to be because of the tan perpendicular to radius theorem, right? So then it means that the gradient of FG will be equal to, now remember, that gradient was 2x for this guy, so it means the gradient of FG is the inverse with a changed sign. So that's going to be -1/2. Now keep in mind, we know the gradient, we know the point F, we can find the point T. So gradient of FG would be y2 minus y1 over x2 minus x1. But remember, we said this gradient is equal to -1/2. So y2, that's 6 minus 0 divided by x2, that's 8 minus t, and this is equal to -1/2. All right, so let's cross multiply there. So that's 2 times that 6 minus 0, which is 12, is equal to, this would be -1 times 8 minus t. So that changes the sign. That would be t minus 8. And if I take that to the other side, so t is equal to 20. Right, so the coordinates of that guy are 20 as well as 0. right? So that's how we will get those coordinates. Right, ladies and gents, so please, if you don't mind, I'm just going to remove all this other stuff. Okay, there's a lot of clutter over there. Okay, I still remember that gradient. Okay, that's 2x minus 10. Okay, that's the equation for this line. Y is 2x minus 10. And all the other points I'm not going to remove, right? Okay, so they now say for the next one, determine the equation of the large circle in the form ax squared plus by squared plus cx plus dy plus e. Right, so I know the center, so I'm going to write it over here. So I know the center of that circle. So that would be x minus 20 squared plus y minus 0 this is equal to, now we need to find the length of the line FG, right? Well, we can do that with ease. We know that FG squared would be equal to x2 minus x1. So that would be 8 minus that 20, or we can say 20 minus the 8. So that's 20 minus 8 squared plus, in this case, that's going to be y minus, so our y is 0, so that's 0 minus 6 squared, right? And what does this give us? That would be 20 minus 8, that would give us 12 squared, which is 144, and negative 6 squared, this is plus 36. Okay, and if I add those two, that will give me 180. And this is FG squared, the radius of the big circle, right? So the line, the equation of the big circle would be x minus 20 squared plus y minus 0 squared, or y squared. And this will be equal to 180. Right, so that's the radius of our circle. But remember, we always say the radius squared. Now we need to simplify this equation and say, well, this is going to be x squared minus 40x plus 400 plus y squared minus 180, and this is equal to 0. So x squared rather, plus y squared minus 40x, and we're going to say 400 minus 180, that would give us plus 220, which is equal to 0, right? So that is the equation of the big circle. Right, and finally, they say the small circle must be translated by k units along the x-axis to touch the large circle internally. Calculate the possible values of k. Right, now I think the trick question there is they said internally. So I want you to just bear with me just for a bit, ladies and gents. I want us to kind of look at this question together, right, and consider the possibilities. So they said they want the two circles to touch one another internally. So, which means if I move the big circle, rather the small circle, right, by whatever units, I want the small circle to touch the big circle internally. That's what they said, right? So that's what I want it to look like. So I want you to think about it, ladies and gents. So what I'm going to do, whatever the y, the x value is there, I want to shift it so that it gets to this point over here, right? So by how many units must I shift it? Okay, So I must shift it by that entire distance, which is over there, right? So what I'm going to do is I'm going to look for the x values, or rather the coordinates of the x-intercepts for both graphs. Okay, so that's 4.6, right? And that's quite easy for the smaller graph. So that's x squared plus y squared is equal to, I think that was equal to 20, right? Equal to 20, right? So at the x-intercept, that's where y is equal to 0, so which means x squared is equal to 20, and so x would be equal to plus minus the square root of 20. I'm going to leave it in that format. Okay, so that's the x-intercept. So I want you to think about it. This value here and that value over there. So this value is minus root 20, and this would be positive root 20. Okay, right, and in this case, for the other circle, right, so for the bigger circle, what would be our y-intercept, our x-intercept rather? So this is x minus 20 plus y squared, and this was equal to 180. So we make y equal to 0. So we've got x minus 20 all squared equal to 180. So x minus 20 would be equal to the square root of 180. Okay. So the square root of 180. All right. So that's the square root. Let's see. So in fact, I'll just leave it as square root 180. Okay. So that's plus minus the square root of 180. So x would be 20 plus minus the square root of 180. Right. So in this case, that would be my my y-intercept, my x-intercepts rather, for the big, for that guy there. All right. So I think the bigger value, what is it? That would be 20 plus root 180. So this would be 20 plus the root of 180. This would be 20 minus the square root of 180. So those are the x-intercepts, right? Now, ladies and gents, I want us to consider the first one. I'm going to move this point to come here so that my circle just manages to touch the bigger circle internally, right? So which means I must actually move it by the difference of the x-intercepts of the big circle minus the x-intercepts of the smaller circle, right? So now what I'm simply going to do is that the first value of k, now please, I want you to note, okay, so I said I'm going to take the x coordinate of the big circle, so that's 20 minus root 180, so it's this value over here, right? And I'm going to say minus square root of 20. All right, I hope that makes sense, ladies and gents. Right, so 20 minus root 180 minus a negative root 20. Okay, so that's 20. All right, so let's work out that first value for k. So this would be 20 plus root of 180, right? And this is minus, oh, actually this will be plus the square root of 20. Okay, so the first value will be 37.89. So that's the first value for k. Right, now the second value for k, ladies and gents, is, so what I'm going to do is, okay, let me just get rid of this circle here. Now, I'm going to take this small circle and I'm going to move it all the way to the side. That's how you'd get the angles, the circles to touch each other internally, right? So I'm going to take that x value and I'm going to subtract this x value, this x coordinate. So I'm taking that entire distance. Okay, so I'm taking that entire distance. So that's 20 plus root 180. Actually, I think I made a mistake in the previous one. I was supposed to say 20 minus, right? I was supposed to say 20 minus root 118, right? And I think I said 20 plus. Okay, so this was supposed to be 20 minus root 180 minus the negative square root of 20, which was the other value there. Okay, so let's see if I calculated it. This was going to be 20 minus the square root of 180 plus the square root of 20. Okay, so the first value is 11.06. Okay, that's the first value for k. Now, I'm going to take that value there, which is 20 plus root 180, and I'm going to subtract root of 20, which is that over there. Right, so let's do that. So the other value for k would be equal to, okay, can I just write it underneath here? So k would be equal to, that's 20 plus the root of 180 minus square root of 20. All right, so let's find out. So that's 20 plus the square root of 180. Okay, so I'm going to say, yeah, that's what I didn't want to happen. So that's minus root of 20. Okay, so that's 20 plus the square root of 180 minus the square root of 20, and I get the value to be 28.94, and that is my other value for k. I hope that was understood, ladies and gents, especially in the context of me just showing you how to do that. All right, and essentially that is it in terms of this question. I hope that you were able to understand it. All right, let's move on to the next one. And now we move on to question 5. So I've just tried to, just to separate it into different sections so that it's easier for us to understand. So let's start with 5.1. They give us there that the sine of beta is 1 over 3, right? And they say where beta is 90 to 270. So now, which means we're going to try and draw a Cartesian plane, right? So first of all, we see that we're given sine of beta equal to 1 over 3. Now remember, sine is y over r, or you can say opposite over hypotenuse, right? So if you notice there, our sine is positive. Now where is sine positive? Sine is always positive in the first quadrant as well as in the second quadrant, right? But in this case, they said beta is an element of 90 to 270. So they say beta falls within these two. So we've got 2 ticks in this case in the second quadrant. So definitely, which means a triangle should be in our second quadrant. So that means that our y value will be equal to 1, right? That's a positive value. And our r value, which is always positive, is 3. So let's get our x value. So we're going to say x squared, that would be r squared minus y squared. So this would give us, so x would be the square root of, right? So that's plus minus that value. So in this case, we're going to say that's r squared, that's 3 squared minus 1 squared. Right, so that's 9 minus 1, which is 8. So we get plus minus the square root of 8. Now in this case, remember, we have to choose which value we take. Square root of 8, by the way, is going to be 2 root 2, right? If you put it in your calculator. So in this case, we're going to take the negative value because we're on the second quadrant and we know that x is negative over there. So that's minus 2 root of 2. Okay, that's 8. Now they said to us, first of all, okay, let me make just some more space there. So they said for 5.1.1, we need to find out what the cos of beta is. Now remember, cos is x over r. So the cos of beta would be equal to, let me just write it underneath, that's x over r, which is in turn equal to minus 2 root 2 divided by our r value is 3. So that would be the cos of beta, right? So let's take that a little bit further down, right, just to create some space. So 5.1.2, it said we need to find sine of 2 beta. So remember, sine of a double angle, we need to know our double angle identities, right? As 2 sine beta, the cos of beta. So that's 2 times. We know sine beta is 1 over 3, right? And cos beta, we just found it. We said that was negative 2 square root 2 divided by 3. And so if you multiply that out, that's 2 times 1 times 2, which will give us negative 4 root 2 divided by 9. And that's how the cookie crumbles, ladies and gents, right? And the last one. Okay, so they say we've got cos of 450 minus beta. Now, what you need to keep in mind is that if you've got a value that is greater than 360, always subtract 360, okay? So, what does that give me? This is cos of, what's 450 minus 360, right? That would give me 90. So that's the same as saying 90 minus beta. Now remember, anytime you add or subtract 360, right, we still get the same thing because every ratio repeats after every 360 cycle, right? Well, except for 10, which repeats at every 180 degree cycle. right? So that's cos of 90 minus beta, but remember, this is the same as the sine of beta, and we know that the sine of beta is 1 over 3. All right, and that is how we answer that question. Right, as we move right along to the next one. All right, we'll try to create some space over there. Right, now for 5.2, they say given that we've got cos squared of exponent 4 of x plus sine squared of x plus times cos squared of x over 1 plus sine x. Right, now they say we must prove that that whole expression is equal to 1 minus sine of x. Now we're going to use our identities here, right? So first of all, we're trying to prove cos to the power 4 of x plus sine squared of x cos squared of x divided by 1 plus the sine of x. This is equal to 1 minus sine of x. Now, I'm going to work from the left-hand side, right? So on the left-hand side, we're given that entire expression, right? There's nothing that I can do on the right-hand side. Everything is in terms of sine and cos. We've got sine there. And in this case, we can't just leave it as is. But on the left-hand side, what I can do is I see I've got cos there and cos. So I can take out a common factor in my numerator. And what's my common factor? That's cos squared of x. And so what would I be left with? Another cos squared of x here, right? Plus sine squared of x, right? Divided by 1 plus sine of x. Now you notice here, this gives us 1, right? So that's our the square identities. Cos squared of any angle plus sine squared of any angle will give us 1. So now we are left with cos squared of x times 1, which will give us cos squared of x. This is divided by 1 plus the sine of x, right? Now, if you look at this, this would simply give us, now you notice we've got cos squared, and we can write this as 1 minus sine squared of x divided by 1 plus sine of x. Now, how do we get it to look like the right-hand side? Now, ladies and gents, remember this represents the difference of two squares, right? So if you've watched my videos on this section, I've shown you how you can write this as 1 plus sine x and 1 minus sine x, right? So you can find the difference of two squares, factorize that, and this is divided by 1 plus sine of x. Now remember, anytime you've got, let's say we've got a squared minus 4, right? That's the difference of two squares. What do? You take the square root of each value, right? That's 2 and 2. And all it is that you change the sign inside. So that's how we get that value. But look at what happens, right? The denominator and what is on the numerator there cancel, and what are we left with? 1 minus the sine of x, and so therefore left hand side is equal to right hand side. All right, I hope the cookie crumbled there, right? And in this case, let's move on to the next one. They say given that you've got cos a minus b is equal to cos a cos b plus sine a sine b. Right, they say use the above identity to deduce that sine of a minus b is equal to sine a cos b minus cos a sine b. Right, now ladies and gents, what I need to do in this question is that I need to write that sine a plus b to look like what I already have there. I need to write it as cos a minus, or rather cos something minus something else, right? Why? So that I can be able to use that, okay? Now, how do I convert sine into cos? Now, you remember sine of a minus b, would you agree with me that this is the same as cos of 90 minus a minus b. Okay, I'm going to use square brackets there. So that's 90 minus a minus b, right? So remember, where am I taking this from? Right, that the cos of 90 minus any angle will become, that changes to the co-ratio that becomes sine of x, right? So in this case, I've said 90 minus a minus b. Right, now remember, I'm trying to write it as cos of something minus something else. But I want to separate the a and the b. So I'm going to say this is 90 minus a plus b. Okay, the negative inside the bracket. So negative times a positive becomes a negative. Negative times negative becomes a positive over there. Now, remember, I still need to write it as cos of something minus something else. So how do I change this? This becomes cos of, I want you to note, I'm going to say this is 90 plus b, group these ones together, so that is a minus a there. So I'm going to take this as one thing, right? And I'm going to take cos a as something else, right? So in this case, now we know what cos of something minus something else is, right? So I want you please to note, this is my first angle, this is my second angle. And what they said here is that if I've got cos of anything minus something else, that will give me cos A cos B, right? So this will be equal to cos 90 plus B cos A, right? Now note, you've got plus on the inside, right? So that's plus, that's sine of 90 plus B sine of A. And ladies and gents, we're going to use our reduction formulae, right? Cos 90 plus B, that's in the second quadrant. Cos is negative in the second quadrant. But remember, once I've got 90, it changes to sine. So that would be sine of B, right? Cos of A plus the same thing there, sine of 90 plus B, that's in the second quadrant, right? And that's going to, sine is positive there, so it will change to cos of B because of that 90, right? The sine of A. Now I can rewrite this, right? Just the other way around. I'm just going to swap these around. So this is going to be sine of A cos B. I'm starting with this one because it's positive, right? Minus, again, I'm going to just swap these around. So that's going to be minus cos A sine of B. And we have proven exactly what they have asked us to prove. Okay. Right. In the next question, they say, hence or otherwise, determine the general solution of the equation sine 48 cos x minus cos 48 sine x is equal to cos of 2x. Now, what I want you to note is that, can you see that my 48 now becomes A and x becomes my B, right? So I can actually rewrite this, because if you look at this, it looks exactly like what we have over there. And we know this is equal to this. Okay, so this on the left-hand side, I can say, well, this is the same as sine of 48 minus x. Okay, so now that means sine of 48 minus x is equal to the cos of 2x. So let's write that down. So sine of 48 minus x is equal to the cos of 2x, right? And we're looking for the general formula. So remember, for the general formula, ladies and gents, whenever I've got sine and cos on either side, I make it into the same trig ratio. And how can I do that? That would be 48 minus x which is equal to the cos of, that's 90, this is equal to the sine of 90 minus 2x. Now remember that sine of 90 minus anything would give us the cos, right? And this is what we did over there. Okay, right, it changes to its co-ratio. Now I've got the same trig ratio on either side. Please do not say you are dividing by sine, right? But because my trig ratio are the same, I'm going to drop the angles, right? So which means 48 minus x is equal to 90 minus 2x, right? Plus k 360, right? And please remember to say k is an element of integers, right? But remember, whenever you are taking an angle for sine, there are two possibilities. The other one would be at 180 minus, right? So I'm going to write it at the bottom there, or 48 minus x would be equal to 180 minus 90 minus 2x, right? Plus k 360, okay? And we remember that k is an element of integers. Right, now let's try and solve this. So I bring the 2x to the other side, it becomes positive. 2x minus x gives me x. And if I take the 48 to the other side, 90 minus 48, that will give me 42 plus k 360, right? So that's my first solution. And on this one, I've got 48 minus x is equal to 180 minus 90 plus 2x. Remember, we are multiplying that negative out, right? So that would be 90 plus 2x. This is plus k 360, right? And if I take that to the other side, that becomes minus 3x. If I take this, bring it back again, that becomes 90 minus 48. That will give me 42 plus k 360. And so if I divide both sides by negative 3, and so x would be equal to 42 rather, divided by 3 will give me negative 14, right? Plus, now remember, I also need to divide that by 3. So that would be k120. You don't necessarily need to change it to minus k120, but it's all the same thing. Why? Because k is an element of integers, and our integers can either be positive or negative. Right, I hope that makes sense, guys. Right, and finally, okay, they say simplify. That's for 6 marks. Simplify sine of 3x plus sine x divided by cos 2x plus 1. Okay, so that's sine of 3x plus sine x divided by cos of 2x plus 1. Now, ladies and gents, we want to simplify to a single trigonometric ratio, right? So what we're going to do is, right, we don't have any identity or formula that helps us to have the sign of a triple angle, right? So I'm going to do this. Let me make my triple angle to be a double plus a single angle, right? Okay, so 2x plus x is equal to 3x. So that's sine x divided by, I'm not going to change the cos 2x just yet, okay? I always say just wait it out until you know exactly what you are doing, right? So this would be equal to, now sine of 2x, now we're going to use our compound angle formula. So this will be sine 2x cos x plus cos 2x sine x. This is just for that guy here. That's plus the sine of x. Again, divided by cos 2x plus 1. So now what we're going to do is we are going to, right, we know what sine 2x is. So this is 2 sine x cos x, that's just this guy alone, times that cos x, right? Plus, this is going to be cos 2x sine x plus the sine of x. And this is all divided by cos of 2x plus 1. Now, if I look at what we have there, okay, I can take out sine x as a common factor, right? All of the terms there have got a sine x, right? The first one will be, without that sine x, becomes 2 cos and cos, so that will be 2 cos squared of x. The next term without the sine x, I've got plus the cos of 2x. And the last term, that's just 1. This is divided by cos of 2x plus 1. Now, ladies and gents, what I am going to do, inside that bracket, I can see that I've got cos squared of x, right? And I've got a cos 2x. So I will convert this guy to 2 cos squared of x minus 1. What it will do is that it will get rid of this one, but I've got two things that are exactly the same. So I've got 2 cos squared of x plus 2 cos squared of x minus 1. That's plus 1. Okay, this guy is that guy alone. So this is divided by, as I said, I'm not going to convert the cos 2x until I know what to do with it. Right, so I've got minus 1 and 1 cancelling out, and these two I can add together. So I've got sine of x times 4 cos squared of x. This is divided by, now I've got cos squared over there. So let me convert this guy to cos squared as well. So this will be 2 cos squared of x minus 1 plus 1. So remember, this is the identity for this guy here. Okay, cos 2x is 2 cos squared of x minus 1. And again, what happens? The minus 1 and the plus 1 cancel. But look at what else cancels. The cos squared. Oops, I just removed that in error. Right? So the cos squareds actually cancel, right? So this guy and that guy cancel. So now I've got 4 divided by 2, which gives me 2. And so my final answer will be equal to 2 sine of x. That's the single trigonometric ratio that they were talking about. Right, so this is a little bit of a, that was a bit of a challenging one, but I hope that you still got it nonetheless. All right, let's move on to the next question. Right, so we start with question 6. We are given a graph there. They say in the diagram, right, the graph of f of x, which is 2x sine 2, this is 2 sine 2x, and g of x, which is minus cos of x plus 45, are drawn for the interval 0 and 180. So they give us the point A there, which is 105 and negative 1, that lies on f. Now they say write down the period of f. Now, first of all, ladies and gents, you realize that the period here is actually, now, first of all, let's look at the frequency. The frequency of f is 2. So remember, we always calculate the period by simply saying the period is always 360 for a sine graph, right, divided by the frequency. So the frequency is 2. So therefore it means that the period is 180. All right, and they say to us, determine the range of G in the interval 0 to 180. Now note in this case, what we are going to do is when we look at the graph of G, right, there it is, it starts over there, and the maximum value looks like 1. But to find that value at 0, that's the minimum value, right? What I'm simply going to do is I'm going to take G at 0. So that will become the minus the cos of 0 plus 45, which is 45. Okay, and if we take negative cos of 45, you'll see that this gives us 1 over root 2 rather. Or you can say this is 2 divided by root 2. Rather root 2 over 2, right? So that would be minus square root 2 over 2. Okay, and the maximum value is 1. So that means that the range in this case, remember we say y is an element of, okay, let me write it there. So y would be an element of, we start from a minimum of minus 2, root 2 rather, over 2. And the maximum value is 1. Okay, right, you can substitute there if you want to verify that it is 1. So you can substitute 135 into that equation and you'll see that it does definitely give you 1. All right, so that is our range. Okay, so we go on to the next part of this question. Now they say to us, determine the values of x in the interval. X is an element of 0 to 180 for which, now 6.3.1, they want to know where is f of x times g of x greater than 0. Now remember, ladies and gents, when I say f of x times g of x greater than 0 simply means that the graphs would have the same sign, and as a result, when I take the product of their y values, it would give me a positive, right? So where are the graphs? Where do they both have the same sign at the same time, right? So if you look at the graph of f, okay, let's start with f. So f would be positive, so I'll mark the positive side of f with blue. So it's positive over there, right? And it starts becoming negative afterwards. Okay, I'll mark the positive with the red. Okay, right, and then what about y? The graph of g rather. So it starts negative. So it starts as a red graph, right? So that's all where it is negative. Then it becomes positive. Now, I've marked the positive with the blue, right? Now, where are they both either red or blue at the same time? I can see the blue. That would be between 45. Can you see both graphs are blue? Between 45 and 90. Okay. So, is there anywhere where they become red? Absolutely none. So, in this case, this would be between 45 and 90, where f of x times g of x will be greater than 0. So, I'll say x is an element of, that's 45, that's excluded, okay, because one of them becomes 0 there. And 90 also excluded because they said just greater than. Okay, we don't want where they are equal, right? So 6.3, by the way, you could have written this as x less than 90 and greater than 45. Okay, right, and then we've got 6.3.2. okay, they want where f of x plus 1 is less than 0. So f of x plus 1 less than or equal to 0. Another way to express this, we can say f of x is less than or equal to negative 1. Now, where is f of x? First of all, -1. Let's go to our graph. Okay, so if we look at the graph of f, okay, actually they've done that for us. So it is -1 at 105, but can you see it would be -1 over there as well, right? If I look at this value, so it's actually at 105, so this is 15 degrees away from 90 degrees, right? So 90 plus 15 will give me 105. So which means it will also be another 15 degrees away from 180. So 180 minus 15, that will give us 165. So this will be 165 and -1. So where is the graph less than -1? So it's in this region over here. So it will be between x is an element of 105 to 165. Okay, right, so we can write that down and say x would be an element of 105 all the way to 165. Now please, I want you to note we're going to include those values, right? And as a result, or otherwise, we can say less than or equal to 165 greater than 105. Right, ladies and gents, I hope that makes sense. Right, let's go to the next question. They say in 6.4, another graph, which is P, is defined as P of x is equals to minus f of x. Now, the graph of P, okay, is actually minus f of x, right? And they're saying to us, D, which is k and -1, lies on P, right? Determine the values of k in the interval 0 to 180. Okay, so now, which means the graph of P is the graph of f, right? But now the difference between f and p is that we have now taken the graph of f and we have reflected it around the x-axis, right? Why? Because I've changed the sign. So in a sense, this is the kind of graph that you would observe. You would see a graph that would be that would look like that. Okay, right. So the blue graph is actually P, right? So they want to know, where is this graph going to be to have values of -1? Okay, so I want you to note in this case, so it would be -1. Okay, so I'm gonna take the graph over there and over there, and I want you to note where the graph of f was 1, the graph of P would be -1. And once again, ladies and gents, I want you to note, okay, that should be at 15 degrees, right? You can actually calculate it. So 2 sine of 2x, right, from the previous one, where is it equal to 1? Right, so this is where sine of 2x is equal to 1 over 2. If I divide by 2 on both sides, then it means that 2x would be the arcsine of a half, which should be 30. And if I divide by 2, that should be 15 degrees, right? So again, so it means the mirror image of that would be at 15, and again 90 minus 15. So in this case, 90 minus 15 should give us 75. Okay, so let's do that. So which means x is equal to 15, or x is equal to 75 degrees. Now remember, so actually I should have said k, right? Because they wanted to know what is the value of k. So k can actually equal to 15, or k can be equal to 75 degrees. Right, I hope that makes sense, guys. And then finally, they say graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H. Write your answer in its simplest form. So what are we doing? Taking the graph of G and moving it 45 degrees to the left. Now remember, which means when I take a graph, so they're saying H of X would be G of X. Remember, when I shift to the left, I add 45, okay? Now remember, what is the equation for G? G is given as the cos, and minus the cos of X plus 45. So that's minus the cos of X, but now X will be X plus 45. Okay, so where I just had X, I'm going to put X plus 45. But remember, there was this 45 that was there. Right? So this guy becomes, I substitute that in there, right? So that's minus the cos of, this is X plus 90. Now please keep in mind, ladies and gents, when I've got 90 plus X, that's in the second quadrant, isn't it? So in the second quadrant, I know that cos would be negative. So that would be minus the negative, right? Now remember, 90 plus X, the cos changes to its co-function or co-ratio. And so that becomes minus sine of X. And that would become the sine of X. That's the graph of H of X. Right, I hope that has been well understood, ladies and gents. And I will leave it there. I hope it made sense. We'll move on to question 7 next. So we look at question 7. It says in the diagram, S, T, and K lie in the same horizontal plane. Okay, so they say RS is a vertical tower. The angle of depression from R to K is beta and TSK is alpha. TS is P meters and the area of triangle STK is Q meters squared. Now they say determine the length of SK in terms of P, Q, and alpha. Right, now in this case, remember when you're dealing with this section, ladies and gents, is that you're first going to work with an angle or with any angle that has the triangle rather with the most information. Okay, so what do we note there? We know that we're given the area of triangle STK, right? So if you go there, we're given the area of triangle STK, which is Q, right? It's that triangle over there. Anytime that you are looking for area, you're going to take two sides and an included angle. So the two sides that are in between the given angle there, right, are ST as well as SK, right? So I'm going to use the area rule with those two sides. So I'm going to say for 7.1, the area of triangle STK, right, is equal to half of, that's going to be ST multiplied by SK, right? This is the sine of angle alpha. Right, now remember they said that the area is Q meters squared, right? That's half of. Now I know that ST is P meters, so that's P, and SK is the one that I don't know, and this would be sine of alpha. Right, and now I can make SK the subject of the formula, so which means I can first I can multiply by 2. So what I do on the left, I do on the right. So multiply that by 2. And in this case, I'm going to divide by p sine of alpha. Okay, divided by p sine alpha. That cancels that and that. So we've got sk is equal to 2q divided by p, the sine of alpha. Okay, so that is the expression for sk. Right, let's go to the next question. They say show that rs is 2q tan beta over p sine alpha. Right, now we're looking for side rs. So we're looking for this vertical pole over here, right? So that vertical pole, where do we have the most information? We've already expressed sk, right? So I'm going to go into triangle RSK. That's the triangle I'm going to go into, right? Now, ladies and gents, I want you to please note this angle of depression. Remember that this angle over here, this is a horizontal, or it's a horizontal line. So if I were to try and draw a 2D image of that triangle, it looks like this, right? So this would be R, this would be S, and this would be K. So what they've given you there is the angle of depression, which is beta, okay? And so what does that mean? Remember, this line here is parallel to that line. So what do we note? It means that that's going to be beta as well. So what I'm trying to show you is that the angle RKS would be equal to beta, right? Because of alternating angles. Can you guys see that, right? Okay, so now that I know that this is angle beta, I've got the side SK, which is adjacent to that angle, and I want the opposite side. So which trig ratio am I going to use? That says adjacent or opposite over adjacent. That's going to be the tan of beta. So I'm going to say, well, in triangle, so let's state first, in triangle RSK, right? So I'm looking at triangle RSK. I've got the tan of beta. So tan of beta would be equal to opposite, which is my RS, divided by adjacent, which is SK. So that's RS over SK, right? But now we already have SK, so which means if we cross multiply there, RS times 1 will give us RS, and this would be SK multiplied by the tan of beta. But we've got an expression for SK, isn't it? That's the one that we got there. So this is 2Q, the tan of beta, divided by P, the sine of alpha. All right, and that's how we are going to express the side RS. And finally, they say calculate the size of alpha if alpha is less than 90 degrees, right? And RS is 70 meters. P is 80, so RS is 70 and P is 80. And they've given us Q, remember that's the area, which is 2,500. Okay, so that's 2,500. And finally, they've also given us a beta to be 42, right? That's 42. And they want us to find, to calculate the size of alpha. All right, so let's do that quickly. So I'm going to substitute into that formula there. So they've given us the side of alpha, so that's 7.3, right? So we're going to say, right, 7.3, we know that RS is equal to 70, that's 2 times, we were given the value of Q, that's 2,500, and the 10 of, we were given beta to be 42, okay, and this is divided by P, and P we are given as 80, right, the sine of alpha. Now, ladies and gents, what we can do is just cross multiply over there. So 70 times 80, okay, so let's whip out our calculator. So 70 times 80, that's 5,600, okay, the sine of alpha, which is equal to 5,000, 10, 42, okay, and this is divided by 5,600, and this is also divided by 5,600, so that cancels with that. And to find alpha, we are going to take the arctan of that entire situation there, okay, so of 5,000, 1042 over 5,600. Okay, so what I'm going to do there is I'm just going to make that into just one thing. So that's 5,000, the 10 of 42, okay, and I am going to close that bracket, and that's divided by 5,600. Okay, so I find the angle alpha to be 53.51 degrees, and that's how we're going to find the angle alpha. All right, hope that has been understood, ladies and gents. And with that, we conclude question 7. Right, so going into question 8, they say in the diagram, O is the center of the circle. Right, they say use the diagram above to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. That is, prove that TOP is 2 times TKP. So we're just proving the theorem that says angle at center is equal to twice angle at circumference. Now, the first thing that you're going to do, ladies and gents, every time we are proving this, so first of all, we're going to make a construction line. And please, when you construct that line, also state it. So I'm going to construct line KO. Okay, I'm just trying for it to be as accurate as possible. Okay, so that's construction line KO. There it is there. You can just extend it a little bit so that you can see it. Okay, so for some reason my line is very skew. So there's line KO over there. All right, so it really shouldn't be rocket science. Okay, so I'm drawing the line KO, and this time I'm just making sure that I just extend it a little bit. Okay, so now let's state that. So we're going to say, right, so in this case, we're going to construct, okay, line KO. All right, we are going to extend it just a little bit. Right, now in this case, we know that, now please, I want you to note, we're going to have O1 and O2. So I'll have O1 over there, and I'll have O2, and I'll have K1 over there and K2, right? So draw line KO such that now I know that line O2, right, or rather angle O2 would be equal to K2 plus angle P, right? So O2 would be K2 plus P. Why is that? These are angles opposite equal sides, right? And please remember that we know in this case that OK is equal to OP because they are radii. So O2 equals to K2, angle K2 plus angle P. But remember that K2 is equal to angle P. Actually, I stated something incorrect there. That's K2 plus angle P. But why is that? Because they are exterior angles on a triangle, right? But we know that K2 is equal to angle P. That's where we've got angles opposite equal sides, or you can say that it is the base angles of an isosceles triangle, right? Now because P is equal to K2, so you can say therefore O2 would therefore be equal to 2 times K2. All right, so you can see that, right? Because P and K2 are equal. Right, similarly, we can say O1, right? So on the left-hand side, O1 would be equal to K1 plus T. Okay, so that would be equal to angle K1 plus T. Okay, and again, why is that? Exterior angles of a triangle, right? Okay, so I'm just going to take this down a little bit so that I have some space. And again, what do I note? K1 is equal to angle T. Again, these are angles opposite equal sides. All right. And finally, what do I say? Right, so we are going to say, therefore, it means that O1 is equal to 2 times K1. All right, so that means if I take O1 plus O2, this will be equals to 2 times K1 plus 2 times K2. Now, if you note there, O1 plus O2, that is that entire angle TOP, right? So that's TOP, right? If I take out the 2 out as a common factor, that's K1 plus K2. And K1 plus K2 is TKP. So therefore, this is equal to 2 times TKP. And there we have proven it, that the angle TOP is equal to 2 times TKP. Right, and that is why angle at center is twice angle at circumference. I hope that makes sense, ladies and gents. Right, so let's go on to the next question. So they say in the diagram, O is the center of the circle, and ABCD is a cyclic quad, right? Quadrilateral. OB and OD are drawn. Right, now in this case, they tell us O1. Okay, so I'm going to put that there. They say O1 is 4x plus 100. And they say C is x plus 34. Okay, and they want us to calculate, giving reasons, the size of x. Now, first of all, I want us to note, ladies and gents, if I look at the relationship between O1 and angle A, right? Do you see that angle at center equal twice angle at circumference, right? So I'm going to say, right, so A, or rather O1 is equal to 2 times angle A, right? And why is that? That's angle at center equals to 2 times angle at circle, right? Circumference. All right, so in this case, it means that the angle, because we know O1 is 4x plus 100, so what would be the size of angle A? It would be divide that by 2. So angle A would be equal to 2x, that's 2x plus 50. So that would be 2x plus 50. But I want you to note, angle A plus angle C are equal to 180. Those are opposite angles of a cyclic quad. So angle A plus angle C equal to 180. That's opposite angles of a cyclic quad. Okay, so now we know the size of angle A, that's 2x plus 50. Angle C is given as x plus 34. This is equal to 180. So that means 3x, okay, that's going to be 84. So this is equal to 180 minus 84. And so 3x is equal to 96 degrees. And of course, ladies and gents, we can divide both sides by 3. And so the value of x would be 32 degrees. All right. Awesome stuff. Let's go to the next one quickly. So they say in the diagram, we've got O, which is the center of the larger circle, and OB, which is the diameter of the smaller circle. Right, so we've got that guy being OB, the diameter. So already that tells me something, that this has to be 90 degrees, right? So remember, we are using the, angle at semicircle, right? So OMB will be equal to 90, right? So they say to me, right, that chord AB of the larger circle intersects the smaller circle at M and B, right? Okay, and they say write down the size of OMB, giving reasons. So we've just stated that. So that would be, the size is 90 degrees, and we said this is an angle at semicircle. Okay, right. And then they say if AB is, all right, so AB is that entire chord there in the larger circle. So that's square root of 300. And OM is 5. So OM is 5 there. And they say calculate, giving reasons, the length of OB. Right, so we want the length of OB, which is this guy over here. Now, ladies and gents, first of all, remember on the larger circle, right, I have got OM making a 90 degrees, being perpendicular to AB, right? So what does that mean? It means that therefore it bisects that line. So in this case, it means AM would be equal to MB, right? So I'm going to state that OM is equal to MB, right? And why is that? Right, we are just simply going to say a line from center. So line from center, from the center rather, is perpendicular to the chord. Okay, right, we know if a line from center is perpendicular to the chord, it bisects that chord. So it makes that AM is equal to, I said OM rather, and this was supposed to be AM equal to MB, right? So therefore, if they are equal and AB is 300, then it means that MB will be equal to square root of 300 divided by 2. Okay, so that means that we are going to divide that entire chord AB by 2. So now we are looking for OB. So then we can use Pythagoras and say, well, OB squared is equal to OM squared plus MB squared. So I know what the value of OM is, right? So they said OM is 5 units. Now we know MB is root of 300 divided by 2 all squared. Okay, and let's find that. So this is going to be 25 plus 300 over 4. Okay, so 300 over 4, that should give us 75, right? So this is going to be plus 75. And if I add those two, that would be 100. So the value of OB would be the square root of 100. And so that will be 10 units. Okay, right. And essentially, ladies and gents, would have earned ourselves a free 16 marks out of that. And now off to question 9. They say in the diagram we've got ABCD, which is a parallelogram with AB equal to 14 units. Right, so I'm going to just fill that in. So that's 14 units. And we know that AD is produced. Right, remember when they say a line is produced, it just simply means it forms a straight line, right? To E, such that AD over, AD to DE is 4 over 3. Now, notice, ladies and gents, when they've given us a ratio, I'm going to express it in terms of variables. So this is 4x over, 4y over 3y. So that's AD over DE, right? That's 4 over 3. And then they say EB intersects DC, right, at F. And they say EB is equal to 21 units. So EB, where is our EB? Right, so it's that entire side there, which is 21. Okay, right. Now they say to us, calculate with reason the length FB. So we want to find the length of AB. Now please, I want you to remember, guys, so we know the whole side EB to be equal to 21 units. Okay? Now, and we know the ratio of these two sides. Now note that they've told us that we've got parallel lines there. So I've got parallel line DF parallel to AB, right? Because that's a parallelogram. So we're going to use our proportionality theorem, right? So I'm going to simply say, ladies and gents, that if I look at that, okay, so I am going to have in triangle EAB, right? So I'm working in triangle EAB, right? So that simply means I am going to take, so that entire side, I'm looking for FB. So I'm going to say FB, right? So that makes this also 3x over 4x, right? So that means it's 4x over the entire side EB, right? So I'm going to say EB over FB, EB over FB. This would be equal to, right? So I took the entire length of EB. So this would be the same as EA over AD, right? So that's EA over AD. So that's EA over AD. Now note, what does EA over AD give me? Right, so EA, and by the way, we need to state the reason there. Okay, all right, I'm going to state the reason. So EA is that entire side, so that would be 7y divided by AD would be 4y. Can you see that? So which means their ratio are 7 over 4, right? And why is that? This is a line parallel to the third side of a triangle. Okay, right, or we can say that that's the proportionality theorem, right? So which means EB over FB would also have the same ratio, 7 over 4. And we know we were given the line EB to be 21. So EB is 21 over FB, which is equal to 7 over 4. And in this case, if I were to cross multiply, that means 7 FB is equal to 21 multiplied by 4. That will be 84, right, divided by 7. And so the line FB would be equal to, so if I say 84 divide by 7, I get 12. So that would be equal to 12 units. Right, I hope that makes sense, guys. So they say prove with reasons that triangle EDF. Okay, so EDF is similar to EAB. Right, so first of all, let's note, it means that angle D will be equal to angle A, right? So EDF is equals to EAB. This angle here, EBA, will be equal to EFD, right? And we note that this angle here, right, would be common between them. And as a result, they would be similar. And by the way, why are those angles equal? Because of corresponding angles. And again, those angles are equal because we've got corresponding angles. So for 9.2, we're simply going to say that angle EDF is equal to angle EAB. So EDF is equals to EAB. That's corresponding angles, right? And we said EFD is equal to EFD is equals to EBA. Again, those are corresponding angles. And finally, we said angle A, angle E is common between the two triangles. So therefore, triangle EDF is similar to triangle EAB, right? So that's EAB. And why is that? Because of angle, 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 right? And finally, ladies and gents, they say calculate with reasons the size of FC. All right, so now we found, remember we were given that AB is 14 units. All right, so we're given that AB is 14 units, right? Now remember what's going to happen here. If I take, now please I want you to note, if I take, we found the side, we found the size rather, we found the size of FB, right? So I'm going to use size FB, right? So we found the size to be 21 units. Actually, no, the entire side, EB was 21 units, but this one was, what was it? 12 units rather. So we found that to be 12 units over there, right? Now, remember, I am looking for the smaller side. Now, remember that this guy here, okay, I just want to use some color so that you can see it. Okay, so remember that this entire side here would actually be also 14 units, right? Why? Because these are opposite angles of a parallelogram, right? So all I'm going to do now is try to find the length of DF, right? Now DF is in the smaller triangle, all right? I'm just going to do it over here. So I know that the smaller triangle divided by the bigger triangle, right? So that means what would be the ratio? The smaller triangle divided by the bigger triangle. Can you see that? Okay, so that means that if I take even in the smaller triangle divided by the bigger triangle, so I'm going to say ED, or rather EF over EB, right, is equal to DF over AB, right? And in this case, what was the reason for that? Okay, we know that this is the proportionality theorem, right? Sorry, I won't be able to fit that whole thing in there. But I know that EF over EB is 3x over the entire side is 7 rather. So in the same way, this is 3 over 7. So which means DF, so that's 3 over 7, right? So which means DF over AB, so DF over AB is equal to also 3 over 7. But I'm looking for the size of DF. So this will be AB, and AB was 14 units. So this would be 14 multiplied by 3 over 7. Okay, so 14, that gives me 14 divided by 7, that gives me 2. 2 times 3 gives me 6. So this would be 6 units, right? So that would be the size of DF. However, I am looking for FC, right? But so FC, or rather let me say DF plus FC is equal to AB, right? These are opposite angles, opposite sides of a palm, a parallelogram, right? So in this case, because I'm looking for FC, so FC would be, AB was 14, right? And in this case, that's 14 minus the 6 that I've calculated. And ladies and gents, you know how the cookie crumbles. So this is going to be 8 units. Okay, right. So that is how we are going to find that side there. Right, and off to the next question. Now, ladies and gents, we'll look at question 10. Right, so in the diagram, we are given PQRS, which is a cyclic quadrilateral. So what I'm going to do is just try to highlight that guy as much as I can. So PQRS, so we know this is a cyclic quad. Okay, so that makes it easier for us to see those exterior angles and to see opposite angles as well. Right, so they say PQ is equal to PR. Now note, they're giving us angles that are equal, so PQ is equal to PR. Now remember, what does that do? It makes PQR an isosceles triangle. So what does that mean? It means that if I look at these angles here, R3 will be equals to Q1 plus 2 because they are angles opposite equal sides. Right, now let's continue. They say the tangents to the circle. Now please note, when we've got tangents, right, we might need to apply the 10-chord theorem or anything related. And in this case, because we've got two tangents, right, we might use angles, or rather tangents from the same point. Okay, so they say the tangents of the circle through P and R meet QS at A, right? So there we see them. And they say RS is produced. Okay, so note, when they say a line is produced, it means it forms a straight line, right? To meet AP at B, and PS is produced to meet AR at C. Now PR and QS intersect at M. Now let's do this together, ladies and gents. I want us to try and do this one together, right? So they say prove, giving reasons, that S3 is equal to S4. Now note, in this case, what we're going to do is, I want to start from S3 and say, well, suppose this angle here was X, right? Which other angle would be therefore equal to X? Now I want you to see. So S3 would be equal to the whole of that Q1 and Q2. Why? It's an exterior angle of a triangle. So this angle would be X as well. But remember, we said that's an isosceles triangle. So it means that R3 would be equal to X as well. But if R3 is equals to X, it would mean that also S4 would be equal to X. So there we can prove that S3 is equals to S4. Now let's write that down. Okay, so we're using deductive reasoning, right? So we're saying S3 is equal to, we said Q1 plus 2. And in this case, why did we say that? We said it's the exterior angle of a cyclic quad, right? A cyc quad. All right. Now S3 is equals to Q1 plus 2. But we said Q1 plus 2 is equal to R3. And the reason we said that is because these are angles opposite equal sides. So these are angles opposite equal sides. And so as a result, ladies and gents, what do we notice again? We see that we've got R3 is equal to S4. And why is that? Because these are angles on the same segment, right? And so what does that mean? It means that therefore S3 would be equal to S4. We've proven that they are equal. Now, let's go to the next question. They say prove that SMRC is a cyclic quad. Now, remember, the only time when we need to prove that something is a cyclic quad is if it is not, or the vertices are not all rather around a circle, right? So they said SMRC. So we're looking at this guy over here, right? They say prove that it is a cyclic quad. Now, what I'm going to do is I'm going to use S4. And if we can prove that S4 is equal to that R1 plus 2, okay, then that would mean that it is definitely a cyclic quad, because we'd use the converse of exterior angles on a cyclic quad. Now what I'm going to do is I already found that Q1 plus 2 is X, right? And so R1 plus 2 is also going to be equal to X. And guess why? Because of the 10 chord theorem, right? There's our tangent there. There's our chord. The angle between the tangent and the chord will be equal to the angle on the opposite side of that chord. So in this case, that's Q1 plus 2. So I'm going to go right into that and say, well, Q1 plus 2 is equal to R1 plus 2. Okay. And in this case, we said this is the converse, not the converse rather. This is the 10 chord theorem. Okay. And then, so in this case, that means that R1 plus 2 is therefore equal to S4. And therefore, it means that SMRC, you remember what we said? We said we needed to prove that they are equal. And so now we can say that SMRC is a cyclic quad. Okay, and why is that? Because we've used the converse of exterior angle of a cyclic quad. Okay, right, so the converse of exterior angles of a cyclic quad. Now, all right, so we have done that. So they say we need to prove now in 10.3 that RP is a tangent to the circle passing through P, S, and A at P. Now, ladies and gents, okay, let me try and remove some of the stuff so that we can see that. Now, what they are saying to us is that suppose we could draw a circle, and that circle passes through P, S, and A, right? So P, S, and A. So if we were to have a circle there, I know my circle is really not circling, right? So in this case, that would mean if there would be a circle and that was a tangent over there, so we could use the 10 chord theorem and say, well, it would mean that P2 would be equal to A2. Can you see that? Right? If we can prove P2 equal to A2, then we can say that definitely PR would definitely be it would be a tangent to that circle there, that imaginary circle that we do not have. Right, so now let's try to do so. Okay, so I am going to say, right, so if I look at what we've just done now, let me start with S4, right? So in this triangle, SAP, right? S4 would be the exterior angle of that triangle, right? And so it would be equal to A2 plus P1. So I'm going to start there and say S4 is equal to A2 plus P1. And what is this? This is the exterior angle of a triangle, right? All right, so we know what S4 becomes. Now I'm going to also use, okay, here's another triangle that I'm going to use. And I'm going to say, right, so here's another triangle, RSP. This triangle over here. Okay. And say, well, but remember S3 as well on that triangle. So S3 would be also equal to R2, angle R2 plus angle P1, right? Why also it's an exterior angle of that triangle, right? Now, we've proven S3 equal to S4, so then what that means is that A2 plus P1 must be equal to R2 plus, okay, so let's see. So S3, we said that's R2 plus P2. Yeah, I made a mistake there. That is plus P2. I see P1 was appearing twice there. So that's R2 plus P2. Okay, so please note, it's this angle P2 as well as R2 there. Now, ladies and gents, I want you to also note, what do we have? P1, okay, so P1 is equal to R2 because of the 10 chord theorem, right? But, so I'm going to say, but P1 is equal to R2, and that is because of the 10 chord theorem. Okay, now if you note this, P1 is equal to R2, so therefore, what does it say? It means that therefore A2 is equal to P2. And so we have proven that A2 is equal to P2, and so therefore it means that RP would be a tangent, is a tangent, okay, right, is a tangent, okay, so that would be tangent, all right, to the circle passing through PS and A. And why is that? Because we've applied the converse of the 10 chord theorem. Okay, so ladies and gents, that is how the cookie crumbles, and I hope that you guys were able to follow this. You've understood it, okay? And Euclidean geometry, of course, these type of questions can really rear their ugly heads when you are in the exam, but please do your absolute best to always practice this section. Otherwise, ladies and gents, we leave it here. I'll see you guys again next time. Sharp, sharp.